Okay, so the next example of a nonlinear system we'll solve looks something like this. Now, again, you have all of your previous techniques, and so to get this thing started, it actually makes the most sense to simply add these two together. And in doing so, you're going to be eliminating quite a bit of stuff. So by eliminating what we have, on the left we'll have an xy, and on the right we'll have a 6. Now, we still have an equation now with two variables, so we have to decide what to do here. The next logical step would be to take the y and set it equal to the 6 over x, so divided by x. Now, make sure that, again, you're okay dividing by a variable only when you're 100% sure it's not 0. And I know that x isn't 0 because if I look back to this equation, if x was 0, that wouldn't be a 6 there. That would be also a 0. So x is non-zero, so I'm able to divide by the variable in this case. Now, once we have y equals 6 over x, I'm going to take this and I'm going to go back into one of the original equations. It doesn't matter which one, just go into one of them. Every place you see a y, replace it with a 6 over x. So I think I'll go into the top one, which will give me a negative 3x squared plus 2x times 6 over x minus 6 over x squared equals a negative 9. I'll go ahead and clean it up a little bit here. So in the second term, the x's divide off and we have a 12 that's left. And in the third term, we get a minus 36 over x squared equals a negative 9. And the last thing I'll do in cleaning it up before figuring out how to solve it is to subtract 12 from both sides, which would be set equal to a negative 21 now. So there's a lot going on. One of the things that I would probably do first is I would actually divide everything here by a negative 3. It keeps our number smaller. It actually turns everything positive for that matter. But I'll go ahead and take this thing and I'll divide by a negative 3. So we're going to have an x squared plus 12 over x squared equals a positive 7. So things look a little bit better now, but we still have the x squared in our denominator. With being an equation, it's perfectly fine to multiply both sides by it to get rid of the x squared part. So that's going to be an x to the fourth plus 12 equals 7x squared. Now, I'm looking at something quadratic-like. It is a polynomial of degree 4, but it does look like it might fit the pattern of a quadratic. So if we move the 7x squared to the left, we can probably factor this. So noticing that an x squared times an x squared would give us an x to the fourth. A 4 and a 3 give us the 12. Make them both negative. We get our negative 7 there in the middle. So we can see now that x squared minus 4 would equal 0, and x squared minus 3 would equal 0. So the first one tells us that x equals plus or minus 2, and the second one that x equals plus or minus root 3. So it looks like we actually have 4 solutions here. We're going to have one with an x coordinate of 2, another one with an x coordinate of negative 2. We're going to have one with an x coordinate of root 3, and one with an x coordinate of negative root 3. Now to find the corresponding y's, we'll need to go back into something from the original. Now here, it makes great sense to go right there. If I take my x's and I plug them in, it's going to spit the y out, and it's a pretty simple calculation for that matter. So if x is 2 and I go back into this guy, I get a 3 for the y. If x is negative 2, I get a negative 3 for the y. Similarly for the root 3's, now I'll go ahead and write that one out so you can see it. If I take a root 3 and plug it in for x, and then I actually rationalize it, I get 6 root 3 over 3, which is 2 root 3. So our y coordinate would be a 2 root 3 there, and just a negative 2 root 3 for that other ordered pair, leaving us with our 4 answers.